What's up, guys? I've got a great video for you today. In this tutorial, we're going to show you how to create a master sketch template using the Spreadsheet Workbench. Let me show you what I mean. If I wanted to design a quad that had 5-inch props and it was a 220 millimeter center to center distance on the motors, and we wanted to use a 30.5 millimeter stack, and we wanted 3M hardware, we were going to use motors that had 16 millimeter distance between screws. Motor hardware on that would be 3 millimeters, and we wanted a 6 millimeter hole underneath our motors to access our shaft. All we would have to do is come into the sketch now and figure out where we wanted our arm to go. If we wanted a stretch, we could come close to the horizontal here, knowing that our props won't interfere, or the vertical. Or if we wanted a wide, we could bring our prop close to the horizontal here. And as long as we don't cross those axes, we know our props will not interfere. Then we could just close this and we could begin another sketch for our top plate, our bottom plate, and our arms, taking all the tedious work out of laying out the motor mounts and your stack holes. All right, so let's get started. First thing we're going to do is create a new file. And we're going to come up here to our Workbench drop-down menu. We're going to navigate to Spreadsheet Workbench. Now you can see we've got a few things that have popped up here. We're going to create a new spreadsheet. Nothing really happens, but you see over here in your model tree that it pops up. So we're going to double click that, and you can see our spreadsheet pops up. And then what I like to do is tile my windows. So I'm going to come down here, I'm going to close the start page. Then I'm going to go to the top where it says Windows, and I am going to come down to Tile, and I'm going to select Tile. Now, it's just a preference thing. I like to have my file on the left here, my part on the left, and my spreadsheet on the right. So the first thing we're going to do is kind of put some information into our spreadsheet. So we're going to define some parameters for the quad, and then we're going to define some parameters for the motor. Makes laying out motor mount holes super easy. I think it's probably the most tedious part of designing a drone frame. So this kind of helps quite a bit. But I'm going to select the first 3 cells here, and I'm going to merge the cells up here in the left. And I'm just going to type in quad parameters. Now this is just a formatting thing, but I like to do it. I'm going to right click it. Sorry, I went a little fast there. I'm going to right click, select properties. I'm going to come here to alignment, and I'm going to select center and center for horizontal and vertical. And then style here, I'm going to select bold. Click OK. Now we can enter in some parameters. So the things we want to enter here are basically what are common measurements. So one common measurement is the prop size. And you'll see why I'm not putting a space here in just a minute, but we're going to go through and label all of these first. So then we're going to do quad size. Then we're going to do stack mount. And then we're going to do hardware. And let's kind of define what these are now. So this right here, prop size is going to be the diameter of the prop. And we're just going to put a little label for the units in here, and it's going to be in inches. Then the quad size. So the size of a quad is kind of defined by the center to center distance on diagonal motors. So we're just going to put here distance from center to center of diagonal motors. And that's going to be in millimeters. And then the stack mount, that's just the distance between the holes on our flight controller and ESC or, whoops. So we're going to just write mounting size of stack. That's going to be in millimeters as well. And then hardware, this is just the diameter of the hardware. Pretty straightforward. So we're just going to populate this with some values here. So the prop size that I use on most of my quads is 5 inches or 5.1 inches. So I'm just going to put 5.1. I like drones that are about 220 millimeters, so we'll put 220 here. And typically I use the larger 30.5 stacks with 3M hardware. So the next thing we're going to do is we have to assign each of these cells with our measurements something that will be able to be recognized by our part. So to do this, we right-click the cell, select Properties, and then select over here on the right, it says Alias. Now the alias for this cell is going to be exactly what we name it. You want it to be exactly like this because you don't want to have to, exit out of your function editor in the part and come back and right-click and remember what your alias is. So I like to make the alias the exact same thing as the cell description, basically. So this is going to be prop size. You can see once I've assigned it an alias, it has turned the cell yellow. So let's go ahead and do this for the other ones. Whoops. Quad size. Okay. And then we will right click, Properties, Alias, stack mount, and then hardware. Right click, Alias, hardware. All right, so now we're ready to come over here into our part editor. We'll just click in this window. We'll come up here and we will navigate to part design. And when that pops up, we will create a new body here on the left. And then we will create a sketch. And we want this on the top plane, bird's eye view. So we've got top here, that's our XY plane. We can either select this or select XY plane there. Press OK, and it pops up into our sketcher. So then we're going to lay out the holes for our stack, our electronic mounting. And to do this, I'm going to start by changing my lines to construction. We toggle it to construction geometry with this button here. And then we're going to create a square. And we will add some constraints. So we know that we want our stack centered on the origin. So we are going to select opposite vertices. And then we will select the center, the origin, and we'll use the symmetric constraint. And you can see that centers it. Then we want to create equal relationship between the two of the sides. So we will select them both, select the equals constraint. And then the last thing we want to do is constrain the length here. And we know that is our stack mount. So here's how we do that. We would select the horizontal, or you can do a horizontal or vertical side. So we'll do the horizontal. And then when the length pops up, instead of entering in 30.5 here, you see this little button here on the left. It's like a little function. I think if we blew it up, it would say like f of x or something like that. We're going to click that, and our formula editor pops up. Now what we have to do is reference our spreadsheet, and it's actually very simple. All we do is type spreadsheet, and it is case sensitive. You can see as soon as I start typing, even if I start typing with just a regular lowercase s, it pops up, but you want to make sure that you select it or type it in fully with the capital. Then you can see spreadsheet, it inserted a dot. So we'll do spreadsheet, dot, and then this is going to be stack mount. So again, as soon as I start typing, stack mount pops up. We press OK. Once we have spreadsheet dot stack mount, you can see the result here, 30.5. We click OK, and you can see that now this is defined by whatever is in that cell with the alias stack mount. It has defaulted to 30.5 because that's what we put in here. So the next thing I want to do is lay out the actual holes, because this is what the square was for the holes of our stack. So I'm going to return my sketching tools to regular, and I'm going to add a circle to each one of these points here, making sure I get that coincident constraint, the center of the circles. And then I'm going to make all of these equal. We'll select them all. And you can either press the E key, or you can come up here to the equals constraint. Oop. Missed them there. You misclick it, clears them all. So we'll select the equals constraint. And then we're going to come here. This is our constraint radius. We're going to hit the drop down and constrain diameter. We'll select it. Remember to click the function symbol here. And we're going to do spreadsheet dot hardware. You can see the diameter came up as 3. Constrain the diameter. And now if we close our sketch, you can just watch this part. You don't actually have to close the sketch. I just want to show you kind of what we've done here. If we close the sketch, you can see we've got our 3 holes. And if you type a new value, let's say 20, it automatically changes them. So we can put mini 20, or you can do, large 30. If we wanted to do 50, I don't think they make drone electronics that large, but you can just easily edit whatever you want here. All right, let's add a couple more useful features to our master sketch template. I'm going to add the length of the arm, and we're going to add a feature that represents the prop. So we'll just grab our line tool, start it coincident with the origin, and just kind of make a diagonal line out there. And then we'll, on the tip of that line, we'll add a circle to represent the prop. And we'll go ahead and define these just like we defined our other elements. We'll constrain the diameter of this circle, select the function symbol, spreadsheet dot prop size. But notice that our prop is in inches and our unit system in our sketch is in millimeters. So we need to convert this. So we are going to just do the math right here in the formula editor, times 25.4. So if you are not familiar, there is 25.4 millimeters in 1 inch. So if we multiply that by 25.4, that'll give us millimeters. We'll select OK. And there we've got a 5-inch prop. We can drag it out a little bit more. And then we'll go ahead and link this length to our quad size. So we're going to use the constrain length, or fix a length. We'll select it, grab the formula editor, spreadsheet dot quad size. But then this is just one arm. This is the total distance we put in here. So we're going to go ahead and divide this by 2. And now you can see that if we wanted to create a quad with these parameters, all we would have to do is select the location of the prop. As long as we don't cross the vertical axis here or the horizontal axis here, we know that our design will not, the props will not interfere with each other. You can come super close there if you want a stretch. You can come real far out here if you want a wide, or if you want a true X, you can just select this line. You can select this point and use the fix onto constraint up here. So for me, the most tedious part of designing a drone frame is laying out the motor mounting holes. So hopefully showing you guys this will make that a little bit easier for you guys too. I know I really like this method. So the first thing we're going to do is define our parameters in this spreadsheet. So I'm just going to go ahead, navigate to the Spreadsheet Workbench. And I'm going to select these three just like I did up here. I'm going to merge them. I'm going to come in here, change the properties, right click, properties. We're going to go alignments, center horizontal, center vertical, style bold. Again, you don't have to do this. This is just something I like to do. Call me picky. And then we're going to title this motor parameters. So the first thing we're going to do is, or the first dimension we're going to define is motor mount. That's going to be the center to center distance of diagonal screws on your motor. Oh. And that's going to be in millimeters. And then we're going to define the size of the hardware. And that's the diameter of the hardware used. Pretty self-explanatory. That's going to be in millimeters. And then the center hole. Sometimes there's a hole in the center of the hand on the arm for the shaft. Sometimes on motors, the shaft sticks below the motor. Sometimes there's a screw in there that you might want to get in there and be able to loosen up. So we're going to call this center hole. And this is diameter of motor shaft access hole. So on the drones that I like to build, typically it's a 16 millimeter diameter of the holes, the mounting holes. So we're going to go ahead and put 16 there. The motor hardware is usually 3M, so we'll put 3 millimeters there. And then the center hole is usually between 5 and 8 millimeters, so we'll say 6. And then we'll come back and we'll assign these all the alias. So we will right-click, properties, click the alias tab, and we're going to call this one motor mount. Then we're going to do the same thing here, right-click, properties, alias, motor hardware. And then right-click, properties, alias, center hole. All right, so let's go back into our part. We can just double click. We can navigate back to the part design workbench if you want, but you can just double click the sketch over here in your model tree. And we'll start laying out some of these features. So first thing I'm going to do is change my geometry to construction geometry over here. And then I'm going to grab the Polyline Tool. So how I'm going to show you to do this, I've done this several times, several different ways, and this might not be the easiest, but the finished product is the least glitchy. There's a couple of other ways I tried doing this, and for some reason, FreeCAD doesn't like when you move the arm around to position the arm after the motor's holes have been defined. So this is the way we're gonna do it. Grab the Polyline tool, and we're gonna make a little short line, and then we're going to make a long line over the center, and then we're going to make another little short line, and we're going to do the same thing going the other direction. So short line, long line, short line. And then we want these lines to be collinear, so I'm going to select these three, and I'm going to make them parallel with the parallel constraint here, and you can see now they're all going to be one straight line. We'll do the same thing with these three. Make those parallel. And then what we're going to do is make these lines perpendicular to each other. So select the two lines crossing each other and make them perpendicular. And then each one of these lines is going to intersect, or we're going to place it onto the origin of our, or I shouldn't say the origin, the center of our motor. So we'll click the line, click the center, and we'll use the fix onto constraint. Same thing with these two. Fix onto. And then we want to make all of these equal in size. So we'll select those three and make them equal. And then we will select these two and make those equal as well. We'll grab our circle construction line, start it on the center here, and we're going to bring that out and make it coincident with the first point. And then we're going to do the same thing and make it a little bit bigger. Fix it onto this outside point here. And then we will grab this point, the circle, and we're going to fix those onto each other. Same thing with these ones. And you can see everything should, because of our equals constraints, everything should fall right on the circles. Now what we can do is add an angle constraint between our arm and one of these lines here. Doesn't matter which one, because it'll move it to whatever the constraint you make it is. So let's make that 45 degrees. And then we can start laying out the actual slots for the holes. Or excuse me, for the screws. So we're going to go back to our normal geometry sketching tools. We're going to put one hole right in the center. Let's see. And if this is getting kind of a lot, what you can do, I think I've showed in one of my past videos, is this button right here. In FreeCAD 2019, or excuse me, 0.19, let's see, yeah, 0.19. Sometimes that's not highlighted. What I've had to do is just close the sketch, open the sketch back up, and it's there. So then you can click that, and it will make all of the constraints disappear. Makes it a little bit easier to sketch when you have something that's starting to get kind of complex. So we'll grab a circle. We'll start a circle right in the center here. That's going to be our center hole. And then we're going to grab the slot tool. Looks like a little slot here with two red dots on it. And then FreeCAD does something kind of weird. I think that it only lets you make slots that are horizontal or vertical, and then you have to go in and delete the horizontal or vertical constraint to be able to move it around. So we're just going to we're going to do some slots on the outside here. We'll do vertical, horizontal, we'll do another one vertical, and then we'll do one horizontal here. But then we have to navigate back into the plane showing our constraints. So I don't know why it does that, but we'll go ahead and toggle those back on. We can zoom in, and you see the horizontal constraint is right there. So we're going to click that constraint and delete it. And see, now you can move the slot, whereas this one, it's only vertical. So we'll go ahead and we'll grab that vertical constraint there. We'll delete it. Grab this horizontal constraint, delete it, and pan up here, delete that. And then we want to put these points here coincident with these points. So what I suggest is moving these kind of close first. That way FreeCAD doesn't kind of freak out and move everything all at once. So we're just going to click that point, and make it coincident. You can also press the C key, which is what I'm going to do for the rest of these, just to kind of make it a little faster. I'll bring this one down here. Bring this one over here. Select those two, press the C key. Let's see, and you can see that FreeCAD is getting a little bit finicky. We got a lot going on here. Here. Over here. So you can see this is kind of tedious, and you can imagine if you wanted to design frames that this could get kind of frustrating. So then what we're going to do is we're going to make all of these arcs equal. And there's already an equal constraint in the slot tool between the inside and the outside arcs. So as soon as you do the inside, the other side should fall in line. So then we're going to go ahead and let's dimension this. So we want to use our constrained diameter. And we're going to select just one of these. And we're going to select the function key here, or the function symbol. And we're going to do spreadsheet dot motor hardware. Okay. All right. And there we go. And then while we're at it, we'll just do the center hole here. Select the function symbol. Spreadsheet dot center hole. All right. And then the last thing we have to do is we have to dimension these here. So this is a little tricky because you want the size of your slots to scale with the size of your motor and the size of your motor hardware. So we're going to get a little tricky here. We're going to constrain the diameter. And we're going to do the inside circle here. And we are going to do it like this. Spreadsheet dot motor mount. And then we are going to do minus spreadsheet dot motor hardware divided by 2. And that gives us a value of 14.5. And then we're going to do the same thing for this outer one, but instead of subtracting half the size of the motor hardware, we are going to add. So it'll be spreadsheet dot motor mount plus spreadsheet dot motor hardware divided by 2. And what that does is it allows it to scale. Let's see, why is that looking so big? I guess that's right. So now, if we close our sketch, we see we've got all of these dimensions here, all of these features here. And if we wanted to make this a 12, and motor hardware for that would be 2M, and the center hole for would be 4. You can see that the motor holes are very easy now. You can just open this template and start drawing the arms. You already have the motor holes laid out, so you can just draw your design or your sketch around those holes. And if you make it bigger, and then another cool feature here, because we dimensioned this as this cross 45 degrees from the arm, if we come in here and we want to move the arm, wherever you put this arm, it's going to be in the correct spot for your motor wires to come out relative to the holes. Whereas if we just left these vertical and horizontal and we moved it up here, and we would have to reposition everything. So this really should help you guys streamline your designs. I think this is kind of the most tedious process, most tedious part of designing a drone frame. So hope you guys enjoyed. If you liked the video, please give me a like, subscribe for more cool videos on how to design drone frames and different drone components. We've got a few good videos coming up. So thanks guys. I'll see you in the next video.